Hi, and welcome to Skill Practice 26 for Polar Chemistry. I'm Shannon. Uh, First, we're going to do what does it mean to say that a bond is polar? Well, one of the atoms involved in the bonds has a greater electronegativity than the other atom, and therefore it has a partial negative charge. 2. Label each of the following bonds as ionic with an I, or polar covalent with a PC, or nonpolar covalent NC. Start by trying out NaCl. First off, we see that Na is a metal, Cl is a nonmetal, therefore NaCl is ionic. Next we have Ff. F is bonded with itself, therefore it is a nonpolar covalent bond. Now we have SO. First we see that S and O are both nonmetals, so it's not ionic. Then we need to find S and O in a periodic table that indicates electronegativity, as seen below. And there we find S and O right there. And then we see that S and O are both significantly different shades of red. Therefore, one has a stronger electronegativity than the other. So it is a polar covalent bond. Now we're going to look at PS. First we see that P and S are both nonmetals, therefore it's not ionic. And so now we need to find P and S in the periodic table, right there. And we see that they're just about the same shade of red, so there's no significant difference in electronegativity, therefore it is a nonpolar covalent bond. Okay, now let's look at BRN. Both B and R are nonmetals, so it's not ionic. We find Br and N in the table right there. And although they are the same shade of red pretty much, so you would think that they would be nonpolar covalent, the fact that when combining N and Br into a molecule, you need 3 times as many Br as N. Therefore, Br has a stronger electronegativity, therefore creates a polar covalent bond. Okay, now we're gonna look at each set of these bonds and rank them in order from most polar to least polar. So first, we see that FF is bonded with itself, therefore is the least polar. Next, we're going to find S and O in the periodic table, right there. Then we're going to find H and C in the periodic table, right there. And we find P and S, right there. Now we're going to look at the shades of different shades of the red. So SO has the greatest difference in shades, therefore it is the most polar. And HC looks practically identical, therefore PS is the next most polar, and HC is after that. Okay, now we're going to look at these ones. We're going to find everything in the periodic table. There's H and N, there's H and O, H and F, and H and Cl. So we see that the greatest contrast in shade happens in H and F, therefore HF is the most polar. Then after that comes HO, followed by HN, and HCl is the least polar. Now let's look at these ones. We're going to find CH, and we're going to find CO, then we're going to find NO, and we find SC. So the greatest contrast is in happens in CO, therefore it's the most polar. Then comes NO.